In this video, I'm going to go over number 117 and number 118. So if you needed to fix and or do those in order to get your score on the 2.2 homework, just do them on a separate sheet and just turn in the separate sheet. I've already recorded the homework in my grade book, so I already know what your score is. So all you need to do for me is do these two on a separate sheet of paper and then turn them in. And they both have the same question. You're being asked where a function is differentiable everywhere. And remember, a loose term for differentiable is that the function must be smooth. So if you look at these, number 117, this is a cubic function, which on its own is smooth everywhere. It has no sharp turns, it's continuous, it's great. This also is a parabola, which on its own is smooth and continuous and no sharp turns. So on their own, the functions are differentiable everywhere, but you're having them meet up at x equals 2. So what you have to do is you have to make sure that the parabola takes off kind of where the cubic ends. So this, for example, if this was at 2 right here, that's kind of where when I draw the function and I enter the parabola at 2, you'll notice there's no break in the graph and there's no sharp turns. I couldn't have had it go, I'm going to move this, for example, like this, because then right here I've got that cusp or that corner. So when you do these, there's two things that you have to make sure happen, and just like I showed you in your notes, and you should branch off with them. So on number 117, what you need to do is you need to make sure, number one, that they seal, that you can't have the cubic ending here and then the parabola picking up here. You have to make sure that the y values are the same when x is equal to 2 so that you seal those two functions together. So the first thing, and I like to branch off like this, is you need to make it continuous. And you don't need to have a discussion about the limits like the Calc Chat did. That's how I know some of you just copied it off of Calc Chat, because you started writing things like the limit as you approach. Really just make sure that the y values are the same there. All you have to do is in the top function, put a 2 in for x, and in the bottom function, put a 2 in for x, and you're going to write an equation that'll be 8a is equal to 4 plus b. That right there is what has to happen for a and b in order for the two functions to seal at x equals 2. Well, also what must happen, I know that always happens because it's lunch, what also has to happen is that they have to have a seamless entry. So perhaps this is at 2 right here. I have to make sure that when I leave the cubic piece at 2, the parabola picks up right where the cubic left off seamlessly. No cusps, no corners, no gaps. I prevented the gaps right here with the continuity. What I need to do now is the way you make sure that it's a smooth seal is you have to make sure that the derivatives approach each other. So what I like to say is that in order to make it smooth, the derivative as you approach from the left has to equal the derivative as you approach from the right, creating a smooth seal right there. So what we do is we go back up to the original function and we take the derivative. And we say, well, that would be 3ax squared. That's got to match up to the derivative of x squared plus a constant would just be twice x. And remember, we need that to happen when x is 2. So now we go plug a 2 in here. And we'd get 12a has to equal 2 times 2 is 4, giving us an a of 1/3. So the a value is 1/3. And how do we get the b value? We go plug 1/3 in and we solve. So we would get 8/3 has to equal 4 plus b. And I don't know how you want to write that out, but if you solve that for b, I don't know, I kind of like to maybe triple everything to get rid of the denominator, and I get 8 equals 12 plus 3b, and I'll get a negative 4 is equal to 3b. b is equal to negative 4/3. So your process for these is, number one, make sure that the function is continuous. Number two, make sure that it's smooth, which requires two things. So for number 118, let's repeat the process. First of all, I'm going to make sure that it's continuous when x is 0. I'm going to force it to seal up. My cosine curve and my line need to seal up there. So your cosine curve kind of looks like this. And what you're doing is you're making sure wherever the line enters, maybe it's on upward, it takes right off from where the cosine. It can't like head this way, creating a cusp. So, and it also can't like start off over here and have a gap. So first thing we have to ensure is continuity. So in order to make it continuous, we have to make sure that the cosine at 0 is equal to a times 0 plus b. Cosine of 0 is the x value at 0 radians, which is 1. This would be 0, so I get a b falling out right away. My b is 1. The other thing I have to do now is make sure, this will prevent any gaps, now I have to make sure that the derivative from the left is matching up with the derivative from the right, because if not, I will get a cusp. They must need to approach each other right there, from the left and from the right. The derivatives have to match. So back up to the original function. Derivative of cosine is negative sine. Derivative of ax plus b is simply a. And I have to make sure that that smooth seal occurs when x is 0. So negative sine 0 is what has to equal a. Sine of 0 radians is 0. So you end up with an a of 0 and a b of 1. And it's incredibly important that you understand that process right there. All right, and the next thing I said I was going to do is number 9. Number 9 from the homework has some algebra that goes on with it. Calculus is fine. I think it's the cleanup of the algebra that was causing you some problems in class. So again, as you go through these, how much time do I have? I have plenty of time. As you go through your homework, you should kind of keep track of the ones you're having a hard time with. We'll put them on the back board, and those are the ones I'll make little videos of. So on number 9, here's my function, and I'm to find the derivative. I need to launch into my quotient rule. So when I do that, our quotient rule set, quotient, I have a hard time saying that word, it says we do low function times the derivative of the high function, low d high. So my high function is x to the 1/2. The derivative of the high function would be 1/2 x to the negative 1/2, which if we write cleanly would be 1 over 2x to the 1/2. So I'd have 1 over 2x to the 1/2. That's the low d high minus high, which is x to the 1/2. D low would be 3x squared. So low d high minus high d low, I will draw a line and I will square below. And never foil that bottom, by the way. I know it's tempting to, but foiling this won't cause anything to cancel because you can't cancel when separated by pluses and minuses. So just go ahead and leave that. It's the top that you need to concern yourself with. So what I would do is go clean up that top so that you can see it. It's really an x cubed plus 1 over a 2x to the 1/2. Then it's minus, and then when we multiply, we add the exponent, so we'd have 3x to the 2.5 or 3x to the 5/2. And this is technically over 1. So if your cleanup went bad, it's probably because you didn't realize that the top there with the complex fraction requires me to get a common denominator when I clean it up. So what I'm going to do on the top is I think I'll just, my common denominator is the product of these two. So I think I'll just say it's x cubed plus 1 on my first cross minus 6x to the, when you multiply you add exponents, so it'd be x to the 5/2 plus 1/2, creating x to the 6/2, which would be x to the 3rd. There's the top, and then that's my crisscross. That's all over 2x to the 1/2. And then don't forget, also on the bottom of the fraction, I have x cubed plus 1 quantity squared. So when I go and clean up the top of my fraction right there, I've got my x cubed minus 6x cubed, creating negative 5x to the 3rd power plus 1. On the bottom, I have 2. I have x to the 1/2. I'm not sure if the back of the book leaves that or if they go square root x. It's pretty inconsistent back there, so you would have to look. I honestly don't care whether you leave it x to the 1/2 or square root x. I know they always say don't leave any radicals in the denominator, but in calculus, that's just fine. You do not need to rationalize that down there. So this is my final answer, and again, you might have some variations on that theme that are perfectly acceptable. On the top, you might have 1 minus 5x cubed. Obviously, I'd give full credit for that. It's the exact same thing. And on the bottom, instead of 2 root x, maybe you have 2x to the 1/2. Again, exactly the same thing. So it's up to you to interpret your answer and see if it's the exact same answer, kind of just disguised, or if your answer truly is not simplified. So both this red one and this blue one are equivalently simplified. It just depends on the syntax of it. So that's number 9. I believe that'll be the answer you see in the back of your book, either the red one or the blue one. And as you work through the assignment, keep track of those that are stumping you. You should be good actually until you get into the mid to late 20s, like in 27. It tends to be the introduction of these rational exponents and these square root problems that tend to cause the most algebra distress. So those are exactly the ones that you shouldn't ignore. Make sure if you don't get them and you go to Calc Chat, make sure if you still don't understand what you're doing, you write that down. We'll put it on my back board, and I'll make a video of that as well. So you guys have a great section 2.3. See ya mañana.